Another thing to talk about is in industrial processes is their water usage. Most industrial processes or human activity, economic activity uses a lot of water. Whether it's semiconductor manufacturing or agriculture, both use a lot of water. The trend more recently has been that in developed nations, industry is using less water, whereas in developing nations, there's a lot of water usage. So when we design a new plant or design a new process, we should give a lot of attention to how efficient it is water usage wise, particularly in developing nations where water is scarce and a lot of water is being used currently. The next part is, you remember earlier I said one of the key aspects of this chapter is to design process from a life cycle standpoint. So let's take a look at the life cycle of a process. At the beginning, you have almost happening concurrently two process steps called resource provisioning or process implementation. They are both like stage one. They call 1A and 1B. At the next stage, you have the following. You have primary process and complementary process. They are also more or less happening at the same level. And the very end of this life cycle, you have recycling or disposal or refurbishing and recycling. So that's what happens, and that is what this PowerPoint says. Resource provisioning and process implementation occur simultaneously, early part of the life cycle. Once you have your process installed and ready to go, the primary process and secondary process, which is the actual process that makes the product, happens. And after the process has been used for some years, like your car, right? You use your Chevy pickup truck, whatever, for 10 years, 20 years, 30 years. It's ready to be retired. That's step 3. It could be recycled or it would be disposed. I mean, if there's not much you can do with it, it's probably going to be disposed. And when you talk of recycling, you can either recycle at the material level or the module level. We'll get to that in just a little bit. Let's take a look at each of these stages and look at what we can do to improve performance. Resource provisioning, what does that mean? It means providing the consumable materials that's going to be used in the process. For example, if it's a plant like Maytag or Whirlpool, they use a lot of sheet metal. Sheet metal to do what? Make stuff like washers and dryers and refrigerators and stuff like that, right? So making sheet metal available is called resource provisioning, the stuff that will be used. And when you are providing this material, or it could be a plastic molding company like Coleman Plastics, right? So you are thinking of what you can do to help this. First thing is use as much as possible recycled materials rather than virgin materials. And the reason for that is, for example, if you're using polymer pellets, if it is virgin material, remember it has to be garnered through this process of excavating crude oil from earth, refining it, and then making pellets. That's a very energy intensive process. But if I already have recycled plastics that are clean, cut up and used again, the energy requirements are much lower. Typically, virgin materials also release more effluents and residues when they are processed. Recycled materials don't. So for a lot of reasons, one of the cardinal rules is use recycled raw material stream rather than virgin. Also pay attention to the manner in which some of the materials like sheet metal that is going to be provided is manufactured or cleaned. You're looking at, are those steps environmentally sound or not, or impactful or not? Process implementation, what does that mean? Well, in this stage, we're looking at environmental impacts that result in doing all the things we need to do to make the process happen. So what are some of these things? Well, you have to manufacture the equipment. It's an injection molding press. You have to make the machine parts, assemble them, deliver them, and so forth, right? So that is one. And the next thing is auxiliary equipment. That is, in addition to the injection molding machine, You will need some exhaust fans to send some of the gaseous products that are released when you mold material. You will need piping, you will need conveyor belts and systems. All of these are what we mean by process implementation. We need to make sure that these are also environmentally sound. For the primary process, so we have primary and secondary process, right? We said they happen simultaneously. The primary process could be, for example, a welding process. We need to make sure that we are using a welding process that uses least resource, presents least toxicity, produces the least waste, and so forth. So it must be environmentally responsible. We also want a process where secondary products are usable within the facility. We should keep hazardous material that are generated to a minimum, or try to design a process that doesn't produce any to start with. Ideally, and this may be at this point in speaking somewhat wishful thinking, every molecule that enters the process should leave the process as a saleable product. Anything that's not saleable is waste that you have to deal with. We are not there yet. Now, complementary processes. They're called complementary because they either precede or follow a primary process. For example, before you can weld two metal parts together, they have to be cleaned. That cleaning process is a complementary process. Or if you are soldering, after the soldering process, you have to clean the freshly soldered surfaces to get the flux removed. So it either precedes or follows a primary process. We have to make sure that complementary processes are also environmentally safe. That is, the cleaning process before welding. What are we doing? Are we using wire brushes? Are we using chemicals? And what are their impacts? We also have to take into account the fact that primary processes and their choice does not dictate unreasonable complementary processes. So they're kind of interrelated. We have to pay attention to that. The last step, right, after the process has run its course, it's at the end of the life. We must have given a lot of thought during the process design to ensure that this process is optimized for disassembly, and making it easier to find out which parts can be recycled and which has to be disposed. Again, like I said earlier, we're looking at material level and module level. So if you look at a car or you look at a computer, right, you can module level, you can maybe salvage the power supply in a computer and use it in another computer, rather than strip the whole thing down to material, because you're losing a lot of embedded energy. So there are many parts. There are some chips within the computer. The motherboard could be salvaged. So you got material level and module level recycling. If you can do it at the module level, the better.